Alright, let's go ahead and start working on number 9 here. So this one is again asking us for integrals. And at first, you might not get why these would be on the exam. Because if you just find the antiderivatives, then you just would get stuff from Cal 1. These are Cal 1 antiderivatives. So why are these on the exam review? Because these are actually improper integrals in disguise. Because as we go to 3, this blows up, this root x minus 3 blows up and goes to infinity. So this function's not continuous at 3. Similarly, this function's not continuous at 1. So both of these are improper integrals, and so that's why they're on the exam review. So let's go take a look at those. So 9. So 9, let's start integral from 3 to 5 of dx over root x minus 5. But now, wait, x minus 3, not x minus 5, x minus 3. But again, with this continuity, by definition, this is the limit as a goes to 3 from the plus of the integral from a to 5 of dx root x minus 3. So what's the integral of 1 over root x minus 3? That's the integral x minus 3 to the minus 1/2 dx. This is a minor u substitution, and I could very much believe you could do this without showing all the work. You would take x minus 3 to the 1/2, and then 1/2 flip it, you get 2. So 2x minus 3 to the 1/2, or 2 square root x minus 3. So this is the limit as a goes to 3 from the plus of 2 times the square root of x minus 3 evaluated from 5 to a, or in other words, limit as a goes to 3 from the plus of 2 times, if I plug in 5, I get 5 minus 3 is square root of 2. And on the other side, I get square root a minus 3 minus. And the thing to note here is I'm going to 3 from the positives, so a minus 3 is well defined under that square root. That's perfectly fine. And if a is bigger but it's getting close to 3, that means this thing is closing on 0. So this is just equal to 2 root 2. So this integral in particular converges, and converges to this number. So that's important thing number 1. And I just realized this is on the wrong document, but that's okay. For part B, we have integral from 0 to 2 dx over x minus 1. And it's the same thing here. This is discontinuous at x minus 1, or at discontinuous. That's a u. It looks like an n. Discontinuous at x equals 1. So this is really integral from 1 to 2, 1 over x minus 1, plus integral 0 to 1, 1 over x minus 1, equals log x minus 1 evaluated from 1 to 2, plus log x minus 1 evaluated from 0 to 1. But because this 1 is the discontinuity point, we have to take limits. So limit as a goes to 1 from the plus of log x minus 1 plus the limit as b goes to 1 from the minus of log x minus 1. Evaluate this from 0 to 1, or 0 to b. This one from 1 to a. And this works out as well. So this is, sorry, this one is a 2. So this is natural log of 2 minus limit as a goes to 1 from the plus of natural log of x a minus 1 plus the limit as b goes to 1 from the minus of natural log x minus 1. Did it again. That's a b. And then plug in 0 minus natural log absolute value 0 minus 1. And so this is natural log of 0. That's fine. But neither of these limits exist. As a goes to 1 from the plus, this natural log goes to natural log of 0. Quote unquote natural log of 0 goes to infinity. So that's the reasoning for that. So therefore this integral does not converge. Integral does not converge. All right, so those are the two types of things that can happen. So be on the lookout for discontinuities if you have definite integrals.